Welcome back to our video series on DevOps and testing, and we are going to start getting into each of the different types of testing that you would use throughout, whether you're a QA person or a DevOps person or sitting somewhere in the middle. Maybe you are currently a software developer and you know a little bit about testing, and you need to, expand your horizons to everything that's out there. So in this video, we're going to dive into specifically unit testing. And what unit testing does is focus on checking individual functions or methods in isolation. So what that means is we're just testing the individual function. We're just testing the one method. Does it return what it's supposed to do? Does it take the correct parameters? The goal is simple. Make sure small pieces of your code behave as expected. So we use unit tests because they provide quick feedback, they're easy to write and run, and they serve as a first line of defense against catching our bugs. And most software developers, this is the first thing that you're introduced to, right, about testing, is maybe you are taught to write your own unit tests. And you know a little bit about how to do this, and it depends on the language, kind of how you approach it. So hopefully this is what I consider to be accessible to those of you with a software background that maybe have never touched any other type of testing. So depending on the language that you're working with, there are a variety of tools for unit testing, right? So, and this isn't even comprehensive because I'm just giving you kind of the popular ones, right? So like Jest for JavaScript, NUnit for C#, JUnit for Java. There are other frameworks that you can use, but the point is that all of these tools automate the process of writing and running tests efficiently so that you don't have to spend a lot of time doing this. So what is it, right? Because we said we're testing each piece of code, like each function, but a unit test really just checks these small pieces of code. And think about it kind of like you're building a Lego set and you're testing each individual Lego brick before you put it into your build. If each brick is solid, then your final structure is going to be much more reliable. So when we are testing each one of these little pieces, we get that fast feedback that we keep talking about that in DevOps, about how the fast feedback helps us move quicker. It's going to let us spot issues really before they go any further. Most unit tests are run by the developer on their system before any of their code is even tried to be checked in or integrated into the build. So we're able to catch bugs early, and when we catch them early, they're cheaper and easier to fix. This also supports refactoring. Refactoring is the concept that you can change your code confidently, knowing that the foundation in which you are building it on is secure. So if you have a problem in one method, and then you are worried about all the places that method is called, you can refactor that method, correct the problem, swat the bug, and know that all of those other places where you're calling that method are going to now receive the update and, work better. Inside of our continuous integration and our continuous delivery, we can run tests on each code push. But again, unit tests are often written locally. Maybe if you're in C#, you're directly in Visual Studio, you can set up NUnit, you can make a unit test, and you can just test it before you even check it in, before it even gets into the pipeline. But you can integrate unit tests in to the pipeline so that when someone pushes their code, you can make sure that you've run those tests. And then documenting behavior. Unit tests really show others what the function is supposed to do. So if the purpose of the method or the function is unclear, then looking at the test can sometimes provide that clarity. So how do we write a good unit test? A good unit test shares some common characteristics. One, it's isolated. That means it does not rely on external systems like databases or APIs. We know data goes into the function, something happens, data comes out, we can test that. It's deterministic. That means the same input should always produce the same output. And we don't have weird errors where we're taking in data and getting different results. It's fast. Most of these are going to run in milliseconds. This should not be something that you're like pushing to the pipeline and then going to lunch. They're readable. Other developers should be able to easily understand what's being tested and the purpose of the test. And then again, the test is informing more about the functionality of the method. And they should be repeatable. They should pass consistently no matter the environment. So if you are unit testing locally, but then you are pushing to production and running unit tests in pipeline and they're not passing, then that's a problem, right? We either need to look at our method or we need to look at our test. So at this point, maybe you're thinking, what goes into a unit test? And here's an example of one. This is a C# example using in-unit. We can see a couple of different things going on in here that inform us about what a good unit test should have inside. So usually in C#, we have the decorator that says test. So this is a method marked specifically as a test for in-unit. And we can really look at the three things that are happening. And you can see that last bullet, what I'm talking about: arrange, act, assert. So we arrange the inputs and the conditions of the test. So clearly this is named add two numbers, return sum, right? So that should be pretty straightforward in terms of what we expect the function we are testing to be able to do. We are calling the add function of a calculator class, passing a 2 and a 3. We are capturing that result, and that is the act. So calling the method we are testing is the act. Then we assert. Assertions verify that the result matches your expectations. So assert.requal, we know if we take 2 and 3 and add those together, we get 5. So 5 is our expected result. And then we are checking, does the value of the result variable actually equal 5? And this is where in-unit or whatever testing framework you're using is going to throw up a flag and say, green, good, great, passes, or red flag, problem. So it doesn't really matter what language you're talking about or what testing framework you're using. The idea of arrange, act, and assert is going to be the same throughout. You're kind of going to always approach these the same way. So writing great unit tests, we have some kind of best practices for the way this should be done. And, that will make your unit tests even better to follow these. We want to test one thing. So if you test one thing per test, this makes it easier to know what's broken. If our add function does a couple of different things in there and returns a value under different conditions, we don't want to try to write one test that tests all of those conditions. We want one test that tests for a certain branch and then another test that tests for a different branch. Maybe the if true result goes one way and the else false result goes another way. We could write two tests to make sure that both paths are returning correct values. We want to use descriptive method names like I showed in the example. This helps clearly explain what is being tested and helps you not lose which of your unit test methods go with different functions just for your own sanity. We want to avoid testing private methods directly. So if the method is private, think about how is it being accessed? Is it through a public API? Is it through some other getter setter type environment in your code? Only test the way that all of the other code would be accessing the method, because if you test it directly, you're not actually experiencing it the way your code base is experiencing. This next one about mocks and stubs. These might be new concepts, mocks are used to verify interactions and behaviors, while stubs provide predefined responses. So mocks are often used in unit testing to isolate the code under test from any external dependencies, which allow you as the developer or to really focus on the specific functionality that's being tested. And then stubs are simpler and just provide fixed values for testing specific scenarios. So when we have like state testing, focusing on outcome and behavior of an actual object, those stubs are going to come in handy to just like hard code in values so that you aren't going to rely on maybe live data or things in your database, or we want to isolate those dependencies. And then keep your test code clean, and maintainable. It's just as important as in your production code what is going on in your tests. So some common unit testing mistakes. Again, testing too much at once. If the test fails and you're testing a lot of different conditions or paths in a particular method, then it's going to be hard to troubleshoot that and determine why your test is failing. So remember, tests should only test one thing. And so if you're testing too much, that's an issue. Break your tests up. If you're relying on external systems, that makes tests slower, sometimes creates indeterminate results, or generally just makes them flakier. So we don't want to reach out to those external systems, use your mocks and stubs and just hard code values if necessary to make that better. Poor naming. So again, using descriptive method names for your unit tests. If someone can't tell what your test does by reading its name, then that's a problem. Go ahead and rename that. And then ignoring test failures. Why are you writing unit tests and then not fixing things if the test fails, right? So if a test fails, fix it. Ignoring failures is going to reduce trust in the entire suite and honestly kind of defeats the purpose. I don't understand why people do this. All right, so kind of in closing here, example scenarios, things you want to think about testing, right? So, anytime we have math logic, these ideas of like we're adding two numbers together, do we get the correct result? Remember, just because you get a result from a mathematical equation or computation does not mean it's correct. And I know I'm using really simplistic examples here of like adding 2 and 3 and getting 5, but if you are writing banking software or software that, actually does mathematical functions like builds graphs for algebra tutoring or something, please make sure that you've actually checked those formulas and they're returning the correct values. String formatting. Things like making sure names and addresses are formatted correctly is something you can test for. Business logic. So, this example, like applying discounts only to VIP users. Is that happening correctly? So looking through your business logic rules, the things that your code should be enforcing, and testing those to make sure those are all working as expected. And then things like input validation, confirming that invalid inputs, like bad emails, are properly rejected. So that wraps up our introduction to unit testing as just a what is it? We will dig in further on how to actually write these correctly and use them in our pipelines in our DevOps environment. So remember, unit testing is not just about finding bugs. It's about creating confidence in your code, speeding up development, and building a foundation for quality at every stage of your pipeline. Hope to see you again soon in the next video as we continue to learn about testing. Thanks so much.